Hi, I hope you're being able to see me over here. Uh, I extend a warm welcome to you all in this webinar on IPv6 technologies. As you must have watched in the trailer video, the Internet of Things is fast becoming a reality. The Internet has evolved to become the central nervous system of the planet, much like the Tree of Souls in the Avatar movie. In order to achieve this realm, we need to add a lot of devices into the Internet. The greatest stumbling block that we are facing in this regard is the paucity of internet addresses. However, this technical speedbreaker has come as a boon to us. We have upgraded our network technology to the next version in the form of IPv6. By this, we have not only solved the problem of address spaces, but have also made great progress in domains like security. I would like to invite Irfan Nasif, Information Systems Officer (COIS), to guide you through the technical details of IPv6 technology. You ask us a question. Your turn, sir. Just stay like this and yeah. Start. No, chal.
Good afternoon, all. I think you are able to see me. Uh, can you just confirm the present? Can you, if you can see the presentation, just do I mean confirmation in the chat message. So okay, I think I didn't get any confirmation, but I can see there are 5 viewers over here. So I think I'll continue with this. Yeah. Okay. So let's go with the presentation. I think so. Let's start with the presentation. Uh, So in this presentation, I'm planning to give an overview of the IPv6, what is IPv6, why we need IPv6, and when. And we'll look into some technical subnetting, addressing, how to configure the routers, switches, and all. Then the third section, I will be looking into the transition methods. Uh, then we'll go for an application layer overview, like what all changes to be done in the application, and we'll have a small look into the government directives also, what the DOT notifications are, what are the timelines and all. Okay, so we'll go on with the introduction. So six, I think any different is a new term, version of the IP address, but it's not only an IP addressing scheme. It's more than that. It's a full-fledged protocol suite. Like it's not only about some addresses in the hexadecimal. There are a lot of other things, like we don't have any broadcast. We have a lot of security features. We have a lot of other things, advantages over IPv4. So why we need IPv6? This is a question the administrators and all ask. Who cares about the IPv6? We already got IPv4 working and it's working really fine. And why we need it? So this is almost similar to the case, like earlier when all the computing was on 32 bits. So the same similar question was there. So whenever a new technology comes, such a question arises. Why we need to? We are already fine with the existing one. But this is not the scenario right now. As in the introduction, sir gave an idea about the IoT, Internet of Things, which the this is really, everywhere we are hearing this term IoT, IoE, and all. So what is this? So in a lot of the things, it's like a lot of new devices are getting connected. Everything, it's a connected connection of the unconnected is defined like that. So your smart homes, smart business, everything like that. A lot of sensors, a lot of devices communicating to each other. So there we need a lot of IP addresses, and which is not possible with the IPv4, which is already exhausted. So this is one requirement of IPv6. We have IoT, IoE. Then we have a new term called M2M. M2M is the machine-to-machine communication, uh, and device-to-device communications. So we are coming to practical world also. Even government of India is putting forward some M2M drafts and all. Recently, the DOT put forward some technical, how to should be the M2M and all. And a lot of M2M service providers are doing the job now. So we need IPv6. We can't just lag behind in this. And see, there are a lot of security issues with IPv4, which we found some way out. Like as such, IPv4 was designed in 1980s and all, when the network was not mature. So there was a lot of issues. Like there was no security, encryption or authentication like that. So we found a way out using IPsec. That was the a network layer 3 security protocol. But in IPv6, we while drafting itself during 1995 and all, the developers already incorporated all the shortcomings of IPv4 in this protocol itself. So we can implement IPv6 very easily without any no need of going for any extra things. So, and another thing is the end-to-end connectivity issues. So in IPv4, the addresses was very less. The public IP addresses was very less. So we found a way out using NAT, this network address translation. So this NATing gave give an advantage that we can use private addresses inside the organization, but with a single public IP. But there was an issue with this also, that we lost the end-to-end connectivity. Network was designed, the applications were designed to have an end-to-end connectivity. But in NAT, we are hiding behind a network, and it's not a security feature. As per the RFC of NAT, it is not at all a security feature. We are finding it as a security feature, but it is we are losing the end-to-end connectivity, so which will overcome in IPv6. We don't have NAT netting in IPv6. It is not required actually, because we have a lot of IP addresses. Now, the another question arises is when we need IPv6 and when we are going for it. So to find an answer, you can just go to these URLs listed over here, this Google's IPv6 statistics, and it shows how much traffic is coming from IPv6. The whole US, the whole Europe, and countries in Asia like Japan and China are already fully deployed in IPv6. I mean, China is leading in Asia. Uh, then why we are waiting for? But I think in India it's very less. I mean, adaptation is there for IPv6. So we have to now. It is the time. It is the time for IPv6 deployment. Now we'll come to some technical things like IPv6. As of IPv6, it's an address. Other than address, there are a lot of other things like other protocols, neighbor discovery, ICMPv6. A lot of things are there. But as a such, it's an address. So what are the different types of addresses? This is listed here. First one is unicast address. So unicast address, as it is, it's a normal address used for one-to-one communications, as same as in IPv4. Now the multicast address, it's all we had a multicast address in IPv4 also, so there is no difference. It's a address of a group. Multicast address means it's an address of a group. If you send any data to that group, all the members of the group will receive that data. So the another thing, new thing, feature of IPv6 is the anycast addresses. In anycast address, it's like so we'll go with the anycast address. So in anycast address, it's like many hosts are having same address. So what will happen is like the traffic destined to this address will be reaching to the nearest host. This is usually used for service delivery, like the services like DNS servers. In the network, you can have a lot of too many DNS servers distributed geographically or something like that. And then all the addresses will be the same for the DNS server. So the traffic destined to this will be reaching the nearest server. This can also be used for load balancing and all. So, and the point to note is there is no broadcast address in IPv6. We'll have only multicast addresses. There is another multicast group, which is this IP address, which includes all the nodes in the network, thereby making it this a broadcast. Now we will have a small look into the scopes, where various scopes of the IP addresses. We have a global unique address. This is globally routed addresses by the ISPs. ISPs will be giving this. If you want to provide an independent address, we can go to the regional registries. For India, we have the IRIN or NITSI, who is providing these IP addresses. So we can get that globally unique address. Now another thing is the unique local address. This is something like similar to the private addresses earlier in IPv4, but this is used not in a NATing and all, because as I told earlier, NAT is not there is not used in the IPv6, and it is not at all recommended. So unique local is it's a provision for like network which will never ever connect to the internet, like a defense network or a test lab or something like that. So no need of getting a unique address from the ISP by paying the cash. So we can have a unique local address. The another thing is the linked local address. That is specific to a segment only. For example, if you have a server with two NIC network cards, then it will be having two link address, or link local address specific to that card, each interface. So that will be only, I mean, local to the segment only. After the router, it won't be valid and it won't be routed after that router. So we'll have a small look at the IPv6 address formatting. Address format, as you know, it's not simple like IPv4. We have 128 bits, uh, and these are represented using hexadecimals. So it will be somewhat difficult to remember this, but it will give you a lot of addresses. So this is like this. We'll have it IP specified over here, and these zeros can be omitted. They can be combined to as double semicolon. That will come to the later slides. Now we'll have the like the addressing rules are like it is noted. I mean the notation is in a hexadecimal notation. So the case is insensitive. You can have from 0 to F. Another thing is the continuous blocks. Continuous blocks, like if you have the quad zero groups, they can be combined as the some double semicolon. So these are the same. Both the addresses shown are the same for simplification. But you can't combine more than two groups of zeros. So you can have only maximum at the most you can have one double semicolon. These are simple technical jargons actually. So like earlier you sometimes you type the IPv4 address also directly in the browser to test some website or something. So this is the how we do it in IPv6. We have to do it in a column. This one. Now we'll have a look at the IPv6 address, general, I mean, prefix, site prefix, and all. So this is the one. We have IPv6 address as 128-bit address. Out of this, we have to at least give 64 bits to a host. It is the recommended way to give 64 bits to the host as an interface ID. And that can be, there are options like this 64 bits can be generated, automatically generated. That's called EUI64. So this is an algorithm. It will generate the 64 bits from its MAC address. You know the MAC address of interface will be 48 bits, but we need 64 bits of as the last 64 bits. So this last 64 bits is made from the 48-bit MAC address plus in addition of 16-bit specified FFE address. So you will get as last 64 bits, and the first 64 bits will be assigned. First, like a small /48 bits will be assigned by the ISP. Then the next 16 bits will be fixed by the organization, the network administrator. So this is the like this one. The first /48 uh, bits will be specified by the ISP itself, and the next 16 you can have different subnets. And then last 64 you should give it an assigned to a host that will be generated by the host itself from the MAC address. So subnetting is similar to IPv4 except that we have 128 bits and we can have a lot of subnets. So since we have a lot of plenty of IP addresses, there is no need of having like sub classes like /28 something like that. We can associate. We can have /64 blocks to subnet. So for an example, for an organization like IOCL, so we should have a detailed plan of how the subnetting should be. So let us say we got a /48 block from our ISP or from our provider independent address. Uh, then we'll allocate /56 blocks to each location. Say refinery headquarters will be getting a /56, marketing HO will be getting a /56, like that. And from there, the marketing HO they can distribute this /56 as different /64 blocks to each subnets. So I think there is an option in this. You can have a, I mean, any if you have any queries or something, you can type it over here. So I'll be trying to answer it. So now we'll go look into the address configurations. So earlier in IPv4 also the addresses can be configured like statically configuration. It's normal. The same thing as in IPv6 is in IPv6. Usually we can do static configuration in servers and routers so that we know the IP and it won't be changing every time. And dynamic addressing. In the dynamic addressing, there is a new feature like we can have a dynamic address without DHCP server. That's a new feature in IPv6, and this is one of the key features of IPv6. Like in IPv4, we had the dynamic addressing. There should be a DHCP server. So this DHCP server will be having different scopes, and they will be advertising the IPs to the hosts. But in IPv6, you can the host can get an IP without the DHCP also. So how that is, we'll look into this issue with this feature. Now this IPv6, dynamic addressing without the DHCP. It's a key feature, as I told. It's a key feature because in the M-term network there will be a lot of sensors deployed all over the network. So it will be difficult to assign. I mean, using a DHCP also. So the sensors can dynamically they can get the IP addresses, which will help in the mobility. Now we'll look into the details of the dynamic addressing. So dynamic addressing also, we have three types of dynamic addressing. One is without DHCP server. So that is called SLAAC. That is stateless address auto configuration. So here, this is a new feature in IPv6. We don't have this feature in IPv4. So what will happen is the steps are listed over here. You can see like when a client is connected to the network, it will generate a link local address. As I told, link local address, it's a specific, the prefix first 128 bit. Out of this 128 bit, the first 64 bit is specified already, and the last 64 bit is automatically generated from the MAC address of the interface. Now we we generated a link local address, but we should check whether this link local address is unique. For that, the client will do the second step. It is told the client will do a network discovery of this link local address, so that we can ensure that this is nobody is using this link local IP. Now in the third step, the client will send a router request, router find solicitation request, so that it will search for any routers in the network. If there is any routers, the client will send a request to that. So it's a multicast address, right? Multicast data packet. Now the only the routers will receive this. Routers will process this. All host may be receiving, but the routers will process this request, and routers over the network will reply to this client with the address scheme, the network prefix. So the client will receive the first 64 portion of from the router's reply, and it will generate the last 64 bits from its own MAC address using this algorithm called EUA64. So we got the address. The first 64 bit was we got from the announcement of the router, and then last 64 bits from the MAC address. Now we should do a duplicate address detection. So this is algorithm where we'll ask for the in the network, is anybody having the same address. So it is an ensurement that nobody is having this one address. So this is how SLAAC works. Means without any, there is no DHCP server working out here. The router is acting as a DHCP server, but it is stateless. Stateless means there is no history like who is having which time, who was allocated which IP. So this is a new feature in the IPv6. So all these requests, duplicate address detection and router solicitation request, routers reply, all are ICMP packets actually. So in IPv6, not like in IPv4, that the ICMP version known as ICMP v6 is having a more role than in IPv4. ICMP v6 is having more role in IPv6. Actually, all these duplicate address detection, router solution, all are ICMP v6 packets actually. So I mentioned this because in IPv6, if you are implementing IPv6, you should not block the ICMP v6 packets using any firewalls. So the IPv6 may not be working fine properly. The next one is DHCP v6. DHCP v6 is the version of DHCP which supports this IPv6. So we have two types of DHCP v6. One is stateful DHCP v6, and the another is stateless DHCP v6. So one is stateful, means here it is normal as in IPv4. It provides the DHCP server will provide the address, all the subnet, the DNS details, domain name details, etc. As normal in the IPv4, same as in the IPv4. But in stateless DHCP v6, here the DHCP will not provide any address. DHCP server will only provide the details like DNS server addresses, domain name addresses, like that. The address for the host will be provided by the router as we had in the SLAAC. So in the SLAAC earlier slides we told that it's automatically the router host will get packet IP address from the router. So similar thing is there in the stateless DHCP v6, except that the DNS server details will be provided by the DHCP server. Now we'll have a small look into the router configurations, how we have to configure the routers or switches like that. So we have to make sure that Cisco, I'm mainly mentioning only the Cisco as we are using Cisco. So Cisco should be, the iOS version should be more than 12.440. All are supporting this IPv6. So it's a normal configuration. Wherever you are typing IP in IPv4, you type IPv6. So in the configuration terminal, you can type the interface details, interface fast Ethernet 00, then IPv6 address, specify the address. Now we are checking, you can check using show IPv6 interface brief. Instead of IP, we are typing IPv6. That's the only changes. Now we'll have a look into the transition to IPv6. So right now we discussed about the IP subnetting. First we discussed about the requirement of IPv6. Then we look into the technical details, what are the different types of IP and all. Now we are looking at the transition to IPv6 from IPv4 network. So aim of the IPv6 transition will be that we need an IPv6 only network. That is the ultimate aim. But as of now, it's not that easy to completely transform to IPv6 only, because there are a lot of applications like SAP and all which are dependent on IPv4 only. It is not IPv6 ready right now. So we'll go for a both method, like the dual stack. So these are, I'll specify the different methods. One is dual stack, then we have tunneling, we have translation. These are three methods. Out of this, the government directive also recommends that we should go for dual stack, and dual stack is one of the easiest method to do the transition. So in this dual stack, as I think you have already heard, we will have both IPv4 and IPv6 stacks in the client. So almost all the modern OSs are having this feature of dual stack inbuilt, like Windows, from Windows Vista onwards. Like in Windows XP, we have limited support for IPv6, but from Windows Vista onwards, we have full-fledged support for IPv6. They can support IPv6 and v4 at the same time using this dual stack method. So this is the best method we have to go for. And for the namesake, I'll just discuss what are the other techniques like tunneling and all. But tunneling, it's like tunneling is used if we are we are having different IPv6 islands. So we have a network at COS having IPv6, and we have a network having IPv6 at the say some refinery headquarters. But the connectivity from COS to a refinery is using an IPv4 cloud. So then in this case, we need a tunnel to this v4 for transferring this v6 packets. So this is tunneling is implemented using some lot of algorithms like 6in4, Terido, etc. Some of the examples of this tunneling. And the another is translation. In translation, it's the least preferred way. It is something similar to the NAT in the IPv6. Here we are translating the v4 addresses to corresponding v6 addresses. So the example is NAT64. It's an implementation, but this is not. There is no as such in the production. We can't use this translation method of IPv6 transition. There are a lot of drawbacks in this one. The main feature of IPv6 was the end-to-end connectivity, which we lost in this translation. So this should be used only in the ultimate, like we don't have any other method of doing, and then we can just use this translation method. But for a production environment, this is not at all recommended. So, and another thing to note is that IPv6 transition should be transparent to the users, like without any degradation of the services. It should be transparent. It should be only the network layer. But I told it should be transparent to the users. But we should have some changes in the application layer also. Even though IPv6 is in the network, the layer 3 of the OSI layers, we have a lot of changes to be done. I told it's a full-fledged protocol suite actually. So we have to do a lot of changes in the routing protocols. The normal OSPF BGP won't work in this IPv6. We need OSPF v3, is the version 3 which support IPv6. And for BGP, we need multi-protocol BGP, MPBGP, for supporting IPv6 traffics. And RIP, we have the next generation RIP-NG, which supports IPv6. So we have to do a lot of changes in the applications also. Like in operating system, I specified earlier, like we need Windows Vista or higher. Windows XP with SP3 is having limited support, but it is having limited support. I specified it is having limited support only. We have to go for minimum Vista. And in Linux, we can have kernels of 2.6 .x or higher, and in Cisco as a specified iOS 12.4 or higher. So, and the one thing to note is, like if you are implementing dual stack, like both stack will be there in the PC. You are having IPv4 and IPv6. So in this case, by default, IPv6 will be getting preference. So this is to be noted. There are some layouts to change this preference, but it is not recommended. Now, another thing to notice in the application layer is like while we are coding or something, we are the developer has to specify that I mean, we should be ensure that there should not be any hard coding of IPv6 v4 addresses in any function or remote function call or anything. And there are some specific, if you are developing any network applications, you have IPv4 specific network function calls that should not be used. So for dual stack, we should have both ways, IPv6 and IPv4, to be taken care. And and more than and the higher level, the layer 7 level, if you are having any web server, then you should make sure that it is IPv6 ready. The web servers usually we are using is IaaS, and as far as I know, I think IaaS 7 and above all are IPv6 ready. And the new version of iOS is 8. It's having a lot of new features also. Or if you are using Apache and all, you have to make sure the version should be IPv6 ready. And then the proxy and remote proxy servers. This also should be IPv6 ready. Like the proxy server, actually we have a scenario like in COS, we are using the Microsoft ISA as a proxy, which is not supporting IPv6. The ISA was very old, and there is the new version TMG that was also not supporting IPv6. So we had to do a new technique in IAS 8, that is the application routing, ARR. So we have to ensure that proxy and reverse proxy servers are IPv6 ready. So, and also another thing is to make sure the firewalls should be able to add rules for IPv6. This was, this is an important point. Like it is very simple to implement dual stack in your routers and all. You have to just add some few commands like IPv6 address, this IPv6 data address in the interface. That's all. So dual stack is done. But security is an important problem. You should ensure that there are access lists applied for IPv6 traffics also. And in IPSS, intrusion protection systems and all, you should make sure that IPv6 specific signatures are applied, or this IPS is combined with the IPv6. Now we'll have a look into the government directives. Actually, GOI, the government of India, is very forward in this IPv6 implementation, and they're very strict actually for, and they are released with the Department of Telecommunications (DOT), the NP cell of DOT. They released the first version of IPv6 National IPv6 Deployment Roadmap on July 2010 itself. And after 3 years, they released the second version of National IPv6 Deployment Roadmap. And according to this roadmap, the version 2, you can access all these details from the DOT, the websites. It is specified, URL is specified, dot.gov.in/ntcell. So according to this roadmap, they have specified the timeline that 1st January 2015, this year 1st Jan was the last date for converting all our public facing websites to IPv6 dual stack mode. So we done almost all public facing websites except a few, like in Indian website or something like that. Indale and Utentering. Utentering is hosted in NAC. NAC, in a discussion with NAC, they told that they are in the process of conversion. That will be done. So we almost followed this first timeline of public-facing websites. Now the next timeline given by DOT is the complete IPv6 deployment over the network. The time is given as December 2017. So for this, we have to do the all the complete planning, like IPv6, how the, we should we go for a ISP independent IP address or something like that. So according to the roadmap, you can download the complete roadmap on this website. I'll just give an overview of this roadmap. The roadmap, the National IPv6 Deployment Roadmap, it specifies or recommends that we should have a step-by-step approach for the complete transition. So these are the some few steps specified in the national deployment roadmap. First one is like appointment of consultants. This is an optional, also optional in case you are not having that much manpower or something, and so they specified the list of consultants whom you can get the services for. You can get all these details in the roadmap. Then we have to go for some assessment. Network should be assessed, what all changes to be done, application services and security. Now we have to go for the plan and strategy, how to deploy all the plans, and then we need for training of the manpower. And now we should get the IPv6 address either from the ISP or from the provider independent one, from IRIN or Nixie. I think the point got Peter training. Sorry. Now pilot testing is there. We have to test it in a small network before doing the implementation in the production environment. Then we should have implementation in the production. Now we can have auditing and network management. The point number 10 is what network management. As far as I know, like we are using some tools like SolarWinds, NMS, and all, which are not IPv6 compliant. So after implementation, this is the one of the important point, network management. You have to look into these applications also. So these are some directives by the GUI. Now for as a conclusion for all these any queries, we have made an mail ID with this one IPv6@indianal.in. You can contact this one or you can contact Mr. Kaushik, manager IS also. And that's all for the day. If you have any queries, you can contact. You can if you have any queries, I think you can write ask it in the question answer area. Thank you.